What if our moon was hollow? Would we be able to hide inside in case some terrible catastrophe destroyed our home planet? Well, the supporters of the hollow moon theory believe that it's actually a real option. The hollow moon is a hypothesis claiming that Earth's moon is either completely hollow or has quite a lot of place inside. The thing is, the moon is less dense than Earth, and it seems to support the idea of its hollowness. But according to science, the reason is the fact that Earth's upper mantle and crust are less dense than the heavy iron core of our planet. Then, there's also the claim that the moon rings like a bell. For almost a decade, between 1969 and 1977, seismometers installed on the moon by the Apollo missions kept recording moonquakes. The moon was reported to be ringing like a bell during such quakes, especially shallow ones. On the 20th of November, 1969, Apollo 12 deliberately crashed the ascent stage of its lunar module into the surface of our natural satellite. According to NASA, after that, the ringing continued for almost an hour. This made some people argue that the moon must be hollow like a bell. Later, lunar seismology researched those shallow moonquakes and showed that they acted differently than quakes on our planet, mostly due to differences in type, texture, and density of the lunar and Earth's rock layers. The speed of sound waves in solids is determined by the medium's compressibility and density. No one has ever found any evidence of a large empty space inside the moon. And still, in 1970, Michael Vasson and Alexander Sherbakov suggested a hypothesis that the moon could be a spaceship designed by mysterious extraterrestrial beings. In 1965, writer Isaac Asimov made an observation that added fuel to the fire of conspiracy theories. He marveled at the sheer astronomical accident that the moon fits so snugly over the sun during total eclipses. The sun's greater distance makes up for the incomparably larger size of the star. As a result, it seems to us that the moon and the sun are the same size. The author added that there was no astronomical reason why the sun and the moon should fit so well. So since the 1970s, conspiracy theorists have been quoting Asimov's words about solar eclipses as evidence of the artificial origin of the moon. Mainstream astronomers disagree with such an interpretation, saying that the angular diameters of the moon and the sun don't perfectly match during eclipses. They vary by several percent over time. Many other pieces of evidence confirm that the moon is a solid body that formed after a planetoid crashed into Earth. In the past, scientists thought that the moon appeared after our rapidly spinning planet got rid of a good chunk of its mass. This idea was suggested in 1879 by George Darwin, the son of the very Charles Darwin, the famous biologist. This theory remained popular until the Apollo missions. Then, in 1925, Austrian geologist Otto Ampferer offered another idea, that Earth and the moon could have formed together from a primordial accretion disk, a rotating disk of dense gas and dust surrounding a young, newly formed star, and used to be a double system. The third theory stated that the moon could have once been a planetoid caught by the gravity of our planet. The modern explanation usually involves the giant impact hypothesis. According to it, a Mars-sized space body hit Earth and created a debris ring around our planet. In the end, this ring gathered into a single natural satellite, our moon. But getting back to the hollow moon theory, at the moment, there's no scientific evidence to support this hypothesis. Seismic observations and other data indicate that the moon has a solid interior with several layers, a thin crust, quite extensive mantle, and a dense core. These days, the idea of the hollow moon is considered to be a conspiracy theory.
There are a few theories about how the moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, There's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the moon would be the same as on Earth. But they are a bit different. The moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the moon's formation these days is the giant impact model. Meteorites coming from the moon are a great source of data for studying the origins of our satellite too. They can tell us even more about the moon than Apollo samples, all because such meteorites come from all over the surface of the moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the moon.
Technological progress does not stand still, and over the past decade, the resolution of images of the lunar surface has improved greatly. Many pits have been discovered on the surface, and some of them are really impressive in size. The largest are hundreds of feet deep. However, technology is not yet advanced enough for us to study the bottom of such pits in detail. That's why a recent discovery is surprising. It turns out that huge pits can extend deep into the rock of the moon. It's a groundbreaking discovery. Let's figure out why. So look at this giant underground cave. Leonardo Carrere and Lorenzo Bruzone from the University of Trento were thrilled to finally confirm the existence of such structures on the moon. They analyzed images taken by the mini RF instrument on board the Lunar Reconnaissance Orbiter in 2010. The original images didn't have excellent resolution, so the authors had to do a huge amount of work, using modern data analysis and modeling techniques. But first things first, why does it all matter so much? Well, instead of building homes on the surface of the moon, we might be able to live inside these natural caves. They could offer protection from dangerous things like harmful space radiation, extreme temperature swings, and even meteorites. According to planetary geologist Wes Patterson from Johns Hopkins, even though we'd still have to bring materials from Earth to make those caves habitable, using them would be a lot easier and cheaper than building bases on the surface. Based on the collected data, the cave is about 150 feet wide and up to 260 feet long, which is just a bit smaller than a football field. It's located in a deep pit called the Mare Tranquillitatis Pit, which likely formed when an ancient lava tube collapsed. Although the moon has no active volcanoes today, billions of years ago, its surface was covered with lava that flowed through valleys, carving out these tubes below the surface. Over time, some of the lava tubes became unstable and collapsed, creating pits like the one in question. NASA's Lunar Reconnaissance Orbiter, LRO, has already found more than 200 of such pits on the moon. It means there could be hundreds of hidden caves waiting to be explored on our satellite. When publishing their findings in Nature Astronomy, the researchers suggested that the caves could offer future astronauts a safe place to live and work, protecting them from the moon's extreme conditions. And extreme they are. One of the biggest challenges of living on the moon is its temperatures. The lunar surface gets extremely hot during the day, reaching about 250 degrees Fahrenheit, and then the temperature drops below minus 200 degrees Fahrenheit at night. But inside the caves, the temperature could stay much more consistent. A separate study done in 2022 used computer simulations to predict that some of those caves could maintain a comfortable temperature of about 63 degrees Fahrenheit. Much easier to manage, right? Unfortunately, getting to the caves won't be easy. The Mare Tranquillitatis cave is over 400 feet below the surface, at the bottom of a steep slope covered in loose debris. It would take some clever engineering to get up and down that slope. The options could be using jetpacks, a lunar elevator, or some other kind of technology. We must find a way to transport astronauts safely. There's also a lot more to discover. Radar technology could help scientists find even more caves and lava tubes on the moon. In the future, a spacecraft with higher resolution radar could even map the insides of the pits that LRO has already found. According to the researchers, this kind of complete survey could help them figure out the best locations for future lunar bases and other explorations. And there's another potential bonus. Those caves could contain water. Scientists have already found frozen water on the moon, under the surface, and in permanently shadowed craters. Tiny amounts are also scattered across the lunar dirt. Water is a critical resource for any moon base, and finding it in the caves could make the idea of living there even more realistic. All in all, this discovery could be a game changer for lunar exploration. Living in natural caves on the moon might be a more practical and safer option than building something on the surface. It could also bring us one step closer to making the moon a place where humans can live and work for the long term. What if we built a huge tower on the moon? A tower that could provide future missions with light, power, and guidance technologies that could help astronauts explore our natural satellite. It's not something from a sci-fi book. It's a novel idea from Honeybee Robotics, one of the brightest space technology companies. The lunar utility navigation with advanced remote sensing and autonomous beaming for energy redistribution, or simply Lunar Saber, is a 328 tall pole. It's capable of holding 1 ton of equipment on top of it. But how could we build such a giant construction? No rocket would be able to hold and land such a giant pole on the moon. And building such a tower on the lunar surface without already existing infrastructure would be next to impossible. So, Honeybee might use the deployable interlocking actuated bands for linear operations Diablo system. It uses a rolled piece of metal and bends it into a deployable cylindrical structure that can support really heavy payloads. It would be easier to build it on the moon because gravity there is only 16% of that on Earth. The structure could serve as the base for Lunar Saber. Power is crucial on the moon, so putting solar panels along the sides of the pole would be super useful. The company is now discussing 2 types of solar panels. The first one is like a yo-yo extended from the top payload holder of the tower. It would envelop the metallic structure and allow access to the sun at all angles. The second option might involve the top part of the tower. It could deploy its booms to hold traditional solar panels and then track the sun. Power supply wouldn't be the only Lunar Saber's task. It would also be able to beam power to other devices, track other devices, and provide communication, light, and energy. Let's talk about these functions in more detail. If one mast of the pole was bathing in sunlight while another was lingering in shadow, the one with excess power would be able to beam power to the one lacking it. Plus, similar power beaming could happen between Lunar Saber and rovers and astronauts in spacesuits. To beam all that power effectively, though, the tower would need to know the precise location of those objects. That's where the second technology would come in. Lunar Saber could use a set of sensors to find and track other objects. Basically, anything in a direct line of sight could be tracked and powered by the tower itself. Lunar Saber could also act as a lunar cell phone tower. It would allow wireless communication in its network. And finally, it would be super helpful for astronauts to actually see where they would be going. Rovers wouldn't need to wait out the 2-week lunar darkness. Floodlights at the top of the tower could provide enough visible light for astronauts and rovers, which would allow them to effectively perform their activities at all times. But guess what? The tower could become even more useful. We could combine several towers in a mesh. It would allow astronauts to communicate more effectively. Plus, power could be beamed even from the other side of the moon. It would enable 2 main applications that have been a thorn in lunar exploration's side so far: constant communication with Earth and constant supply of solar power. The thing is, explorations on the other side of the moon are quite tricky, which limits the area of scientific research to the side directly facing Earth. But a strategically placed mesh of lunar sabers could allow communication back to Earth, and we would be able to explore the dark side of the moon. Since at least half of our natural satellite is always lit up, if we placed lunar sabers correctly around the surface of the moon, there would always be at least one bathing in sunlight. That one sunlit tower would then wirelessly transmit power to others in its line of sight. This process would keep going until power was beamed to the main astronauts' base, supplying them with power even in the cold lunar darkness. Unfortunately, at the moment, such technologies look unrealistic. We're not close to having wireless energy transmission over long distances. Even on Earth, we still need to use batteries and wires. It might be easier to launch many satellites into orbit around the moon than to create a network of giant communication towers.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us. Or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant. It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now, let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. 2 other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1,000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses, These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. Their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the Moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the Moon, too?
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon, and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
Every April, a group of scientists observes the faint glow of asteroids passing by our planet. One year, they realized there was something weird shimmering in their telescopes. The team expected it to be another asteroid, but they ended up very surprised because what they discovered was an unusual space rock that didn't consist of the minerals that usually make up asteroids. It was made of silicate, the material mostly found on the moon. They named it Kamo'oaliwa, which is a Hawaiian word that means wobbling celestial object. The rock didn't match any near-Earth asteroids scientists had already been familiar with. Instead, that piece had a pattern of reflected light similar to that of the moon rocks astronauts had brought back from NASA missions. This fragment turned out to be a quasi-satellite, which is a kind of asteroids that orbit both our planet and the Sun. it repeatedly circles Earth and has a quite unusual tilt. That's the reason you can only see it in the night sky once a year. The fragment is pretty shy, too. It never gets closer to our planet than 9 million miles. That's almost 40 times as far away as the Moon. Plus, this space body often hides in the shadows. Scientists have figured out the piece won't stay in this orbit for a long time. It probably arrived at its current position about 500 years ago, and its orbit is likely to change in the next 300 years. This fragment may not be alone out there in space. There are at least 3 more similar near-Earth objects. They may have all come from the same place. Researchers aren't sure yet about the nature of the rock, but they can find out more about this unusual space object if they send a spacecraft to collect samples and bring them to Earth. That's something China's space agency is planning to do later this decade. Now, the Moon appeared in the middle of chaos. There are several theories about how that happened. The first one claims the Moon used to be just a wandering body, similar to an asteroid. It formed somewhere in our solar system. Once, it approached too close to Earth and got captured by our planet's gravity. The second theory says that our planet was spinning so quickly that some material broke off and started circling around it. One of the largest pieces was the Moon. The third theory says that the Moon was formed at a time when our planet was going through its own formation process. But today, the most widely accepted theory goes like this. Once, a long time ago, but not in a galaxy far, far away, Earth collided with a Mars-sized planet. The debris and clouds of dust from the collision gathered around our planet and started circling it. Eventually, something that we today know as the Moon formed there. Apollo missions brought more than 1/3 of a ton of soil and rock from the lunar surface. These rocks show that the Moon had mostly the same building materials as our planet. This might mean they have a common history. If the Moon had been formed somewhere else and had been eventually captured by the gravitational force of our planet, it would have a different composition. Also, if it had been created at the same time as our planet, or had once broken off, there would be the same minerals on both the Moon and Earth. But the minerals on the Moon contain less water. Plus, our planet's natural satellite is rich in materials that form fast at high temperatures. Now, the Moon isn't the only space body in the solar system with a mysterious past. Hippocamp is Neptune's moon, discovered in 2013. It's the smallest moon of this ice giant, a mere 21 miles across. It's very close to Proteus, the biggest of Neptune's inner moons. And no, Hippocamp is not a place for big African mammals to spend the summer. Scientists think Hippocamp probably formed from debris after Proteus collided with a comet. If Hippocamp had entered Proteus's orbit from some other place in our solar system, the bigger moon would have either swallowed it or booted the tiny moon away. But not even Proteus itself is among the first generation of Neptune's moons. It was formed from the remains of the planet's earliest system of moons. Those first moons were destroyed when Neptune captured Triton, currently the largest of its moons. The main evidence proving the collision was likely to happen is the fact that Triton circles around Neptune backward, unlike other moons orbiting the planet. Neptune captured Triton from the Kuiper Belt. That's an area filled with icy objects and rocky debris stretching beyond Uranus. That means Hippocamp is a third-generation moon. Kinda like a second cousin twice removed or something. Now, the Sun also had a turbulent past. Our star appeared about 4.6 billion years ago. It's hard to study its early stages of life since that happened 50 million years before our planet was even formed. But recently, a team of researchers has discovered crystals that are over 4.5 billion years old. Hidden deep within meteorites, they've revealed some things about the past of our Sun. Before the planets were formed, our solar system had consisted of a central star and a massive disk of dust and hot gas spiraling around it. As the dust and gases cooled down, they turned into minerals, including the crystals found in the meteorites that landed on our planet. Those ancient materials were irradiated, unlike some younger substances. Researchers think something might have happened to the Sun after those crystals were formed. Perhaps the activity of our star was less intense then. Or maybe, for some reason, these younger materials couldn't travel to the areas where irradiation was possible. Dwarf planets give us a chance to sneak a peek into the ancient years of the solar system. Around 4 billion years ago, Jupiter's, Saturn's, and Neptune's gravitational forces joined. They sent asteroids and comets hurtling across the solar system, making them collide with different planets. All the dwarf planets from the Kuiper Belt, for example Pluto, Eris, Haumea, Makemake, have their own moons that likely formed after some powerful collisions. Icy debris in orbits similar to Haumea's, for example, can prove the theory of an ancient collision. The debris it created simply didn't have enough energy to float away from the dwarf planet's gravitational pull. Ceres, another dwarf planet, has ammonia-rich clays on its surface. Ammonia isn't stable at the temperatures prevailing on Ceres, but there's plenty of this substance in the outer solar system. It means that Ceres was probably formed in those outer parts and got kicked inward. After all, the gas giants were migrating a lot at those early stages of the solar system. Or the dwarf planet could have formed in an asteroid belt, and ammonia somehow, let's say after a powerful impact, appeared on the dwarf planet. Ceres might help scientists understand icy moons better. The ocean floor on Earth has a high concentration of carbonate minerals, and some parts of Ceres have them too. This means this dwarf planet is like some sort of fossilized ocean world. Many exoplanets, a term used for planets outside the solar system, have also gone through pretty intense collisions in their early stages. This double star system is more than 300 light-years away from us, and its stars are at least 1 billion years old. Even though it's not young, this system still shows some signs of swirling clouds of dusty debris that haven't cooled down yet, which isn't something you'd expect from a star system of this age. This debris is still warm. It means there might have been a strong collision of two planets or some other space bodies of similar size in that region, and relatively recently. So hey, everybody just simmer down. Dust particles circle around a young star. They stick together and grow bigger with time. That's how planets form. The leftover dust often settles in some distant cold areas. An example in our solar system is the Kuiper Belt. It's located far away beyond Neptune. As solar systems evolve, those particles keep colliding until they're so small they end up being pulled into nearby stars or kicked out of the system. Uranus spins on its side if you compare it with the rest of the planets in our solar system, and the only way we can explain it is a powerful collision in the past. Something much bigger than a regular comet or some other space body of similar size likely hit Uranus and knocked the planet on the side. It was probably a planet twice the size of Earth. It could be a protoplanet. This is a space body made up mostly of ice and rock that orbits a star and is likely to develop into a planet sometime in the future. Anyway, the fallout from the impact smothered the core of Uranus. It prevented the heat inside the planet from escaping. This might explain why Uranus has extremely cold temperatures on its surface. Man, bring a jacket and a blanket.
The moon's surface has millions of craters, but something else has drawn a lot of attention to it. A giant rare hole that turned out to be a tube. It was found when the Japanese lunar orbiter was gathering data around the moon's skylight, the tube's entrance. Researchers found a specific echo pattern that suggested there was a hollow area. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field and the pit could swallow it whole. It's irregularly shaped and 427 feet in diameter. Scientists think that there could be secret caves, a tunnel system, or an entire geological wonderland under the surface. It could be a good shelter for astronauts that land on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. It has a wide range of temperatures, low atmosphere, and no magnetic field that would protect life on the surface from things like radiation or harsh sun rays. Astronauts wear spacesuits, but they can't protect them over long periods of time. But a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, which results in an empty tube. Our planet also has lava tubes, but they're not as big as the one found on the moon. There's a special type of tree called a moon tree. It's grown from seeds that were taken into space during one of the missions and then returned back to Earth. You can find this kind of tree growing across the US. Earth is 27% bigger than the moon and far more massive. Our gravity is stronger. If you drop a rock on the Earth, it will fall faster. 150 pounds on Earth is just 25 pounds on the Moon. The Earth has numerous satellites circling around it, but the Moon is the only natural one. Our Moon was formed during a big collision of the Earth and one more planet the size of Mars. This happened around 4.6 billion years ago, shortly after the Sun and our solar system were formed. After the collision, a cloud of vaporized rock went into orbit around our planet, cooled, and shaped into a ring of small solid bodies. They later got together and became the Moon, leaving craters as a reminder of this collision. If you're standing on the surface of the Moon, your shadow will be darker than on Earth. This is because there's no atmosphere to scatter light and create lighter shadows. One of Jupiter's moons, Io, has hundreds of volcanoes and pretty wild eruptions, sometimes sending plumes 250 miles into the atmosphere. These eruptions happen because of the extremely strong gravity this moon is exposed to. Its insides tense up and relax in those periods when it gets closer to and then further from Jupiter, which generates enough energy for insane volcanic activity. It's not just planets, even quite small space bodies sometimes have moons. In 1993, researchers discovered a 20-mile wide asteroid and its 1-mile wide moon. You'd need 400,000 moons to match the brightness of our central star, the Sun. The moon reflects the light it gets from the Sun, but it doesn't produce its own. That brightness depends on the angle between the moon, the Earth, and the Sun. Our moon is around 32 Earths away from us, and 29 Earths at its closest. When the night is dark and clear, it seems like you can touch a full moon. But if you wanted to do it, you'd have to travel up to 250,000 miles. Still, there is water on the moon. Not puddles or lakes, but grains of water ice exist in permanently shadowed parts near the moon's poles. Scientists think that water got on the moon a long time ago, during a period when both the moon and Earth were constantly struck by asteroids and comets, which contained water ice. This process may have even helped us get our own lakes and oceans, not just the moon's icy water. Newer research says that the moon's interior already had water, and it went to the surface during volcanic activity. The same might have happened on our planet too. Out of 200 moons in our solar system, our moon is the 5th biggest one. Jupiter's moon Ganymede is the biggest one, almost 1.5 times bigger than ours. Apollo 11 was the mission where humankind first landed on the moon. It was a very important moment, broadcast all over the world. But it was almost interrupted by a huge windstorm that was going on in Australia back then. Parker Dish was placed there, which was something we used to get the broadcast signals from the moon. The moon is not a perfect circle. It's more in the shape of an egg, with the thicker end pointing toward us. This shape is derived from its rotation. A full moon can keep you awake. Studies showed that people experienced less deep sleep, and it took them longer to fall asleep during the full moon period. It wasn't about its brightness, but the lunar cycle that influences our internal body clock. Each year, the moon is moving away from Earth because of the interaction between the moon's gravitational force and our oceans. In 1 year, it moves around 1.5 inches away, which means that in around 600 million years, it will be 14,600 miles further from Earth than it is now. This number isn't accidental. That's the time when total solar eclipses will stop happening. Humankind hasn't set foot on the moon in a few decades, but footprints there are still fresh because there are no winds up there, so these tracks can stay there for millions of years. The moon has its own time zone called Lunar Standard Time. Time is different on the moon, so a year there is divided into 12 days, considering each is as long as our month. Days got named after astronauts who walked on the moon. The moon calendar starts the moment Neil Armstrong stepped onto the moon in 1969. There are possible energy sources for living beings on one of Saturn's moons. It has an ocean under the surface, and it may feature some chemical reactions similar to those that help certain forms of life on our planet survive. The moon used to have active volcanoes, probably during the time of the dinosaurs. Molten lava hardened on its surface billions of years ago, which helped create unique lunar craters, but the volcanoes have been dormant for a long time now. The moon has earthquakes, or rather, moonquakes. Just like our planet, the moon also has a crust that goes through changes and shifts. Shaking occurs when its crust warms and expands. or it can even be caused by meteorite impacts. Moonquakes are not as strong as earthquakes, but can last way longer since the moon doesn't have enough water to prevent seismic vibrations. The moon has a big range of temperatures because it doesn't have an atmosphere. During the day, it can go up to 200 degrees Fahrenheit, but at its poles, the temperature is around -400 degrees Fahrenheit. In 2019, astronauts discovered a strange space phenomenon. The moon was crossing in front of the sun, and at one moment, it seemed like it stopped and then started moving backward. It's the same optical illusion like when you're driving on the highway and pass a car that's slower than you. At one moment, as you move ahead, it may appear like it's going backward. The crust of the moon is not equally thick in all its parts. Some are up to 37 miles thick, while others are much thinner. The moon itself doesn't change colors. When sunlight goes through our atmosphere, it reflects off the moon and makes us see it as pink or red. Sometimes there are particles of dust sent into the atmosphere, and in combination with sunlight, they give the moon an orange glow. The moon doesn't have a dark side. There's only a far side that we can't see from the Earth. The moon spins on its axis once and makes a circle around the Earth, all in the same amount of time, which is why we only see its one face the entire time. All planets in our solar system have at least one moon, except for Mercury and Venus. Mercury has less mass than our planet, so its gravity is lower than ours, around 38% of the Earth's gravity. That means 100 pounds on Earth would be 38 pounds on Mercury. Because of the weaker gravity, and since it's so close to the Sun, Mercury wouldn't be able to have its own moon. It would probably crash into Mercury, or even go into orbit around the Sun, and someday even get pulled into it. Venus most likely doesn't have its moon because it's also too close to the Sun.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the kraken or leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.